Alright guys, how's it going? So we're going to run through the second lab, and this time we're going to build our VPC and launch a web server. Alright, and so again, like I did in the previous video, I'm not going to edit anything out. I'm just going to run this video through, like go through everything, and if there are any errors or any mistakes like we did in the first one where the grades didn't submit everything. I don't know, because the code maybe had a glitch or something. You can see that. You won't be worried. Just refresh and then you're good to go. So let's start with this one. Again, ideally you need two screens, but if you don't have two screens, just divide your screen into two like we will in a second, right? But right now, just cool. So in this lab, you use Amazon Virtual Private Cloud, Amazon VPC, to create your own VPC and add additional components to produce a customized network. You will also create a security group and then configure the customized EC2 instance. You will then configure and customize an EC2 instance to run a web server. You will launch the EC2 instance to run in a subset in the VPC. Definition of VPC enables you to launch AWS resources into virtual network that you define. This virtual network closely resembles a traditional network that you would operate in your own data center, with benefits of using the scalable infrastructure of AWS. You can create a VPC that spans multiple availability zones. After completing this lab, you should be able to do the following: create a VPC, create subnets, configure security groups, launch an EC2 instance in a VPC. This should take about 30 minutes to complete. And service restrictions. And here we get to see the infrastructure that we're about to build. So you see we have we're going to be in the AWS cloud, obviously. We're going to use the region Virginia East US 1 or 2, East US 1. You will create the VPC. We'll use two availability zones. So we'll create the lab subnets. We'll create two subnets, basically a public subnet and a private subnet, and both of them will have the option. And then I think we'll duplicate that, and then they will have the ability to access the internet through the internet gateway, and we'll have these CIDR notation that we can use. Okay, so let's just go ahead and start lab. I should have clicked on this before I went through the full rant so that you don't have to sit here and wait 3 minutes, but we're going to sit here and wait 3 minutes for the lab to spawn. This should take up about 30 minutes. The first lab was supposed to take us about 40 minutes and we finished in about 31 minutes, so yay. So yeah, let's just go through this one quickly as well and sit here for the next 3 minutes. You can skip ahead and I'll be quiet now for 3 minutes. So you can use this time to get some water. Good. I have mine here. Or coffee or whatever. Yes, I'm restless. I hate staying waiting 3 minutes. 1 minute more. Okay, so the lab is green. The lab is available now. Okay, so this is a mistake that we did. So and it's good I got this on camera. So if you create a lab and you don't sign out of the lab and we just close out of the account like we did, this will happen when you're trying to log into the lab the next time. So you just have to click here to log out, and then you come here, just close it out, come back and click on it again, and this time it will take you straight to the console, right? So good thing I didn't edit it out. Yeah, so let's just get right into it. So again, first we will take this, we will do this, then we will shift it this way a bit so we can have more space. Should we then increase the size a bit? I'm trying to see. Okay. Nope. Okay, that should be good. Alrighty, so let's start. We're done with all this. Task 1. In this task, you use the VPC, Virtual Private Cloud, and many more options in the VPC console to create multiple resources, including a VPC, an internet gateway, a public subnet, and a private subnet in a single availability zone, 2 route tables, and a NAT gateway. Sounds like it's a lot, it's really not. So let's just start. So we will search for VPC. You can click it over here, but I will advise you just search it here so that you can have a feel of basically the environment. You can see what's going on. Begin creating a VPC. In the top right of the screen, verify that you are in United States, North Virginia, obviously not physically, but this is what you chose, so be there. Choose the VPC dashboard. Yeah, choose the VPC dashboard link, which is toward the top. Okay, yeah, that one. Yes, we're already here. And then choose create VPC. Note, if you do not see the button with the name, choose the launch VPC wizard button. I didn't see that one. I saw this, and so you should probably see it too. So let's go. Configure the VPC details in the VPC settings on the panels on the left. So choose VPC and more chosen. Under name tag auto generation, keep auto generate selected. However, change the value from project to lab. So here I will advise you type it out, especially in the other labs, just so you can get a feel for it, especially if you're not somebody who does coding, you understand when we get to the other lab. So let's just go with this one. Keep the CIDR block set to 10.0. Okay, yeah, 10.0.0 /16. We're good. And then what's it? So if the instructions don't mention it, just leave it. So instructions don't mention IPv6, so we'll just leave it as it is. All it said is 1 availability zone, 1 public subnet, so make sure it's 1, 1 private subnet, we're good, and then 1 availability zone NAT gateway, right? Oh, okay, wait, we're here. Okay, expand the customized subnets, CIDR blocks. Okay, expand this, and then we'll change them to 10.0.0 and just change this to 24. Cool. And then in the second one, that's the private subnet, we'll just change the 128 to a 1. So it's 10.0.1. 0.1.0/24. Cool. All right. Then we get to the NAT gateway in one availability zone that we did, and the endpoint VPC will have to change it to none. Okay. Keep these two enabled, and then in the preview panel on the right, confirm the settings you have configured. That means you come up here and you see over here, right? So then we can show details, and you can see that this is what we've created so far. So by putting all these things together, this is what we have created. We've created the lab VPC. We have created the VPC in US East 1A, because the availability zone A. We've created a public subnet, a private subnet, and what else? Yeah, and the internet gateway. Okay. Yeah, private public subnets. I think that's pretty much it. So just make sure that everything is the same. So everything that was here, you can see lab subnets public is here. Lab subnets private is also here. And then the route tables. What's happening today? So lab route table public, route table private, and then the internet gateway, lab igwe and lab nuts. Okay, so at the bottom of the screen, so we'll scroll down here, and maybe I should just zoom out so you can see. So this is basically how your infrastructure should look like. All right, so after we selected everything, we show one availability zone, none, create VPC. So this will take a while. Okay, it will take probably like a minute or two. So we'll just sit here and be quiet and wait. Again, you can go and drink some water or something, but it will take just about 2 minutes to finish configuring this. So we'll just wait. So just create VPC. Water break. And we're ready. Okay, so then it says click on choose view VPC. Sorry, a VPC wizard has been provisioned with the VPC with the public subnets and private subnets in one availability zone with the route tables for each subnet. It also created an internet gateway and a NAT gateway. To view the settings of the resources, browse through the VPC console links that display resource details. For example, choose subnets. Okay, so they said we should go and choose subnets, and then you see this, right? Now it's not fully done because they will ask us for some things over here that we need to check out. And so, like I said, everything you do, click refresh because it's not always done. Now you see more keying. Okay, so just refresh, you'll be fine. So we went to, where are we now? We went too far, didn't we? Oh, yeah, we did go too far. So view VPC, so we'll go to subnets, you can see, so we have the lab the private subnet, the public subnet, right, that we just created. Then we'll go to route tables. Also hit refresh. I mean, it's already here now, but you can see the private route table and the public route table. Right, to view the route tables in detail, okay, so this shows what we have done. So it shows that I don't know if you can see this. Should I zoom in? Okay, let's zoom in. Nope, didn't help. Yeah, so the zooming didn't help, but you can see what we did. So basically we've created the image I showed you first. Actually, you know what? Cool. So we have created the first part of this. Where is it? Okay, we'll have to scroll down a lot. Sorry. I went too far. Cool. So we created the first part, the availability zone. We created a VPC, the lab subnets, the private lab subnets. We created the route table and then the internet gateway. Yeah. Okay, so we're going to do the next one. Shoot. Okay. All right, let's scroll down to here. Okay, so we've created the first part. An internet gateway is a VPC that allows communication between the EC2 instances and your VPC and the internet. The lab subnet public is TOS1A. Public subnet has a CIDR notation of 10.0.0.0/24, which means it contains all IP addresses starting with 10.0.0.x. The fact that the route table associated with this public subnet routes 0.0 network traffic to the internet gateway is what makes it public subnet. Okay, a NAT gateway is a VPC resource used to provide internet connectivity to any EC2 instance running in private subnets in the VPC without those EC2 instances needing to have a direct connection to the internet. The lab subnet private is TOS1A. Private subnet has a notation of 1, which means it contains all IP addresses starting from 10.0.1.x. So next we're going to create additional subnets. In this task, you create 2 additional subnets for the VPC in the second availability zone. Having subnets in multiple availability zones within a VPC is useful for deploying solutions that provide high availability. If you start, I'm sure by now you're taking the course, you know what high availability means. It means basically having the whatever you are building in more than one availability zone, so that if one somehow crashes, you still have your data available. After creating a VPC, as you've already done, you can still configure it further. For example, by adding more subnets. Each subnet you create resides entirely within one availability zone. Understood? So in the first navigation page, we're going to choose subnets. Yeah. And then we're going to first you will create a second public subnet, so we'll create subnet. And then we'll select lab VPC. So you could see there are 3 over here. Just choose the one that has lab VPC in it. And then the subnet name, so we'll either copy this or type it out, but laziness. So yeah. And then availability zone, select second one. So yeah, see there's A and then there's B. This is the second one. So US East 1B, because we are creating them in the second availability zone. Okay, right? CIDR notation, this one just stays the same. IPv4 stays. So again, like I said, if it doesn't mention it, you don't touch it, but the one it does mention, you fix it. So we're supposed to have 10.0.2.0/24. All right. and then we'll just click create subnet. Right, I hope I didn't miss anything. Okay, so you can see that we just created lab subnet 2. Then configure the next one. So I have to just create subnet again, same lab VPC, and then lab subnet private 2. That's the name. Then the availability zone, again choose the second one, US East 1B, and then then we'll name this one 10.0.3.0/24. Like I said, 10.0. Okay, cool. Alrighty, and then just create. Okay, so now we have created the private subnets. The second private subnet was created. You will now configure this new private subnet to route to internet-bound traffic to the NAT gateway so that resources in the second private subnet are able to connect to the internet while still keeping the resource private. This is done by configuring a route table. A route table contains a set of rules called routes that are used to determine where the traffic is directed. Each subnet in the VPC must be associated with a route table. The route tables controls routing for the subnet. In the left navigation pane, so we're going to go to route tables. Again, just refresh so that you can see everything. Select private lab. In the lower pane, we choose routes. Now the destination 0.000 is set to target the NAT gateway. This means the traffic is destined for the internet and will be sent to the NAT gateway. The NAT gateway will then forward the internet traffic to the internet. Okay. The route table is therefore being used to route traffic from private subnets. So choose subnet association there. You created this route table in task 1 when you chose to create a VPC and multiple resources in the VPC. That action also created lab subnet private 1 and associated that subnet with this route table. Now you have created another private subnet lab, blah blah. You associated this route table with the subnet as well. So in the explicit subnet association panel, choose edit. So you can see first. I think I'll pull this up. Explicit subnet associations, edit. When you edit it, choose lab subnet private 1 and then lab subnet private 2. So just look for the ones that have private in their names and click them among these two and then save associations. Cool. You will now configure the route table that is used for public subnet. So then we'll now select this one and we will deselect this one, right? Because it says here select the RTB blah blah and deselect any other subnet. In the lower pane, we'll go to routes. We'll see that the destination takes them to the internet gateway, which means to be sent straight to the internet via this internet gateway. You will now associate this route table to the second subnet created. So we'll go to subnet associations again, and where are you? Now we'll click on edit subnet associations, and this time we'll do the public one. So public, and we'll save. So then you can see from here that the two subnets that we did were the public ones, and then these two are the private ones. Cool. So choose save association. We did that. Your VPC now has public and private subnets configured in 2 availability zones. The route tables you created in task 1 have also been updated to route network traffic for the 2 new subnets. So you can see that we have created this the phone, we're not there yet. So we've created these 2 now, and the next one we're going to do is the security groups. So let's go. Okay. So in this task, let me just refresh this. Again, like I said, always just refresh just in case. In this task, you will create a VPC security group which acts as a virtual firewall. When you launch an instance, you associate one or more security groups with the instance. You can add rules to each of the security groups that allow for traffic from the instrument, blah, 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 blah. So then we just go to security groups that's down here, and then we'll create a security, so when we get to security groups, we'll just create a security group, and then we will label it web security group. Because we are lazy, we'll just drag and drop. And then we'll enable the description, and we'll call it enable HTTP access and drop. And this one, it says choose X. I'm sure they're talking about like the previous. What did I do? Okay, I didn't put it there. Cool. All right. Choose X to remove, blah, blah. Don't panic. There's no X. I know there's no X. Just go there and then click on this, and then look for the one that has lab VPC. Okay, go to inbound pane, the inbound rules pane, and then add a rule because there are no rules. And the rule is HTTP traffic. There it is. And the source should be anywhere IPv4. And the description permits web requests. Okay, we'll just scroll down, don't touch anything else, and just create group. Let's just make sure one more time we got everything. Type HTTP IPv4 anywhere, permit requests. Create a group. Perfect. So task 4. So first, just refresh this. Yeah, come on. Okay. In this task, you will launch an Amazon EC2 instance into the new VPC. You will configure the instance to act as a web server. In the search box to the right of the services, search for and choose EC2. There we have it. Then we will launch an instance. So just go to instances, or just do it from where we were first. Go to launch instance. We'll give the name web server 1. Perfect. When you name your instance, AWS creates a tag associated with the instance. Okay, so a tag is a key value pair, and the value pair, the key for this pair is name, and the value is the name we entered, which is web server 1. So choose an AMI to create the instance. In the list, you have to choose the Amazon Linux, which has already been selected for us anyway. And then what's next? So also keep the defaults. Keep this one, Amazon Linux 2023 AMI. Don't change it. Right. The type of Amazon machine image you use to determine you choose determines the operating system that will run on the EC2 you launch. Okay. Choose an instance type. In the instance type panel, choose the one that says T2 micro. We're already there. It's already T2 micro. No need to touch it because it is fine. But normally you would see T2 nano, T2 small, T2 medium, blah blah blah. So just leave it at T2 micro. Cool. And then the instance type defines the hardware resources that are assigned to it. Select the key pair to associate with the instance. Key pair name, we'll choose Voki. The Voki key pair you selected will allow you to connect to this instance via SSH after it has launched. Although you will not need to do that in this lab, it is still required to identify an existing key pair or create a new one, or choose to proceed without a key pair when you launch an instance. Alright, configure the network settings. So next to the network settings, choose edit. Right here, network settings, okay, choose edit. And then lab VPC, the subnet, you should choose lab subnet public, not private. Lab subnet public 2. Where is it? Okay, so we chose lab subnet public 2. You can see that. Let's see, mosquitoes. Auto assign public IP, enable it. Next, you will configure the instance to use the web security group that you created earlier. Under firewall security groups, choose select existing security group. Select existing, okay. And then the existing one will choose web security group because that's the one we just created. Oh, it's right there. Okay, so the security group will permit HTTP access to the instance. In the configuration storage section, keep the default settings. Okay, so leave this. 8 GB GP3, it's explained over here. So the default settings specify that the root volume of the instance will host Amazon Linux guest operating system that we specified earlier, will run on a general purpose SSD GP3 hard drive that is 8 GB in size. You could alternatively add more storage volumes, however that is not needed in this lab. Configure a script to run on the instance when it launches. Click on expand details. Advanced details. Advanced details is right here. Cool. And then hold on, give me a second. Yep. So click on advanced details. Scroll to the bottom of the page, then copy and paste the code shown below. Yeah, so copy this code and paste it here. This script will run with the root user permissions on the OS, on the guest OS of the instance. It will run automatically when the instance launches for the first time. The script installs when the instance launches for the first time. The script installs a web server, a database, a PHP library. Then it downloads and installs a PHP web server. I mean, I don't code, so I can't really read this, so we just have to take their word for it, I guess. At the bottom of the summary panel on the left side, choose launch instance. You will see a success message. So you can see we are crossing the 1 hour mark, the 30 minutes mark. So because we had 1 hour 30 minutes and we're here. So when I was doing it the first time, I fell asleep. So when I woke up, I was trying to continue and I realized the success wasn't working. Mainly because the timer had run to 0, so it had already turned off the lab, and so everything I was doing wasn't working. So in case you fall asleep, just know that is why it is not working. So you see a success, and then we'll go to view all instances when you scroll down. Wait until web server 1 shows the 2 out of 2 checks. You can see that, just refresh. You can see web server 1 is running and initializing, so it's not done yet. So you just have to sit down and wait. So just refresh again and just sit down and wait till it is done. This may take a few minutes. Choose the refresh icon at the top of the page every 30 seconds or so to more quickly become aware of the latest status of the instance. You will now connect the web server running on the EC2 instance. Still not done. So we're gonna wait. Oops. Still, come on. This taking forever. I'm not editing it out, so you're just going to have to sit in silence with me. Come on. Okay, so finally ready. 2 out of 2 checks passed. So now it says we should select web server 1 and then copy the public IPv4 address. Yeah. In the details lab, open a new browser tab and paste the public DNS value and enter it. Okay. Try to do this. I mean, I don't think you have to use the incognito, but let me just say continue to site. Okay, great. So it works. I mean, you could have just done it over here as well. Like just go to a new tab and just do it. But hey, I like to make, hold the phone. Okay. So open a new browser tab. So cool. So I ran into this problem when I was doing my lab. That's why I did the incognito tab. So I think because I'm still logged in, so when I use the same thing and I create a new tab, it just gives me this error and says, you know, timed out, blah, blah, blah. But you could just see that the same code I pasted is the same one I put in the incognito tab, and I am right here. Okay? So just use the incognito. Perfect. All right, then. What's next? You see a web page displaying the AWS logo and instance meta values. Yep, metadata, instance ID, availability zone. These are the values with the AWS logo. So we got it. So the complete architecture you deployed is this. So we're done actually. So we finally built the whole architecture. What's happening? We finally built it. So we built first we got the region right. We built the VPC. We built the what's it called? The subnets, the private and public subnets. We built the NAT gateway. We routed them. We duplicated, or we created, the public and private subnets in different availability zone. We added a security group that decides whether we can access or can't access it. So now we can submit and wait for our results. Yes. Ooh. So you can see here the public route tables for the public subnets and then the private route tables for the private subnets. Perfect. So you can see our score this time is 30 out of 30. So congratulations. I guess what did we learn? I should have done that before I closed it, didn't I? Okay. Oh, this one didn't say anything like that. Okay, that's fine. Okay, so basically we created this architecture and we're good. Alright, so we created a VPC, we created subnets, we configured the security groups, and we launched an EC2 instance into a VPC. So yeah, lab 2 is done. Have a good one.